Okay, this video is going to focus on what is section 2.3, which is truth tables for compound statements. And in fact, I'm just going to do one compound statement in this video, but I'm going to go through it slowly. And if you don't know how to do a truth table, this is maybe the first video you should watch because I'm going to go through it. So what we're going to do is we're going to do a truth table for this compound statement, not A and not B. I'm going to sort of walk through how to do that, what that means. For the exams on chapter 2, the quiz and the final exam, if you can make truth tables, that is a lot of the work right there. That's sort of one of the key skills that chapter 2 is trying to get you to have. Oops. Okay, so when we're constructing our truth table, we need to draw a grid. So in the last video for 2.1 and 2.2, you saw a lot of these grids for the example, the conjunction truth function. We're going to need to construct a table. So we need to know how many rows and how many columns to make it. The number of rows, and the answer to both of those is easy. The number of rows is going to be 2 to the n. Well, what's n? N is the number of atomic statements that are involved in the compound statement. Well, we only have 2 atomic statements, A and B. So we have 2 atomic statements. So 2 to the second power, 2 squared is 4. Okay. If we had 3 atomic statements, suppose it was A and B in parentheses, and if A, then C. Well, then we'd have 3 atomic statements. We'd have A, B, and C. We would need 2 to the third power, which would be 8 rows. Okay, but here we need 4 rows. How many columns are we going to need? Well, we're going to need 1 column for every statement involved in the compound statement. Okay, what does that mean? Well, we've got the 2 atomic statements. We've got A and B. Those are parts here. So that's 2. We have not A. That's 3. We have not B. That's 4. And then we have the whole conjunction, not A and not B. That's 5. So if you look at it, these are all of the different statements, atomic, compound, involved here. So we need a column for every one of those. So we need 4 rows, 5 columns. So I'm going to go ahead and draw that. Now you'll see that I'm making the first columns narrow and the last columns wider. You'll see why. The reason is, well, we'll get to that in a minute. The first thing I want to do is talk about how we're going to sort of identify rows and columns on these tables. So the one on top is row 1, row 2, row 3, row 4. So sometimes we'll be talking about the tables and we'll need to be able to specify things. Column 1, column 2, column 3, column 4, column 5, and so on. So that's pretty straightforward. Okay, so now the question is, how do we complete the table? So the first thing you're going to do is up on, what you might think of as the top row, but it's just up above row 1 on top of the table. You're going to put your atomic statements in alphabetical order. That may not be the same order they show up. If this was not B and not A, right, we would still put A first and B second here. So always put them in alphabetical order. That's easy. Then, what we want to do, well, before I get to that, what we want to do is we want to then fill out the columns. So this will be the column underneath a statement is going to be that statement's truth column. So this is A's truth column. This is B's truth column. We want to fill out these truth columns under the atomic statements with all of the possible combinations of inputs that those could have. And if you think about it, there's 4 possible combinations. They're both true. First is true, second is false, first is false, second is true, or they're both false. We only have 2 truth values, so those are all the combinations we have. Now that's easy to do with if there's 4, but what if there's 8 or 16 or 32? How do you know you've got all combinations? Here's how you do it. And in fact, here's how you do it even if you only have 2 or 4 rows. Just follow this recipe. Okay. What you do is in the first column for your first atomic statement, you just make the top half trues and the bottom half Fs. There's always going to be an even number of rows because the number of rows is 2 to the n power, and that's always going to give you an even number. It's going to be 2, 4, 8, 16, 32, and so on. So you make the first half true, the second half false. That's in the first. Then you move over one column and you alternate by groups of trues and falses that are half the size as the one you just did. Well, we just did groups that were 2 trues, 2 falses. So I'm going to now alternate by ones, true, false, true, false. If you do that, you will always get all of the combinations of inputs. I'm going to take, there's like a little detour here. I'm going to come back to this truth table for not A and not B in a minute, but I just want to show you something. Suppose the truth table had 3 atomic statements. Suppose we're doing a truth table for this, where we had P, Q, and R. So we need 8 rows. You do exactly the same procedure. We have 8 rows. The first one, top half T's, bottom half F's. Then you'd move over by 1 and you alternate by groups half as big. So instead of alternating by 4s, you alternate by 2s. True, true, false, false, true, true, false, false. Then you move over 1 more and you alternate by groups half as big as this. Well, this was 2, so now we're going to alternate by 1s. True, false, true, false, true, false, true, false. Okay? If we had 4, there would be 16 rows. And then the first column would have 8 trues and then 8 falses. Then we'd alternate by 4s, then 2s, then 1. Okay, so you get the idea. Always do that procedure, and you will have all combinations listed out. And you will also get maximum points on the quizzes and the exams. Okay, so now let's go back to the truth table we're actually doing, this one for not A and not B. We've done the first part. We filled out the truth columns for the atomic statements. Now what we want to do is build up from the smallest compound statements, we've already got the atomic statements, to the largest compound statement, which is this one, the overall statement we're doing the truth table for. And then we're going to, for each one of those, we're going to fill in its truth column. And we're going to use the truth function of the operator that statement's main operator to tell us how to do that. Okay, so the first thing we're going to do is up here, we've already done the atomic statements. Now we're going to do the compound statements. First, the compound statements directly built up from the atomic statements, but then we're going to get more and more complex until in the last column we get the overall statement that we're doing the truth table for in the last column. Okay, now what we're going to do is we're just going to fill out the truth columns for all of these compound statements. And then we're done. How do we do that? Okay, well I'm going to walk through this, and I'm going to walk through every single cell in this table one by one so that everyone knows how to do this. So the first statement that we're doing is not A, and that's a negation. The main operator is this tilde. So I'm just going to put our negation truth function down here to remind us of what that truth function is. And I'm going to just temporarily make this cell green to indicate that this is the one I'm going to fill out first. Okay, so I want to fill out this cell. What do I do? Well, this is a negation, not A. What is this negation negating? It's negating A. So the input is here. The negated statement is here. Okay. So now I'm going to look down at my table and say, okay, when phi is true, what is not phi? Well, if phi is true, not phi is false. Okay, which means if A is true, then not A is false. So I'm going to take this F, and that's what I'm going to write here. is an F. Okay, and I'm just using this table. This table says that when the negated statement is true, the negation is false. Well, the negated statement is true, so I put a false here. I'm just going to go down every row and do the same thing. Okay, so now I want to do this cell. A is also true here, so it's going to be exactly the same. The negated statement is true, so not phi. The negation is false. So if A is true, not A is false. So I put an F there. Next, this cell. Well, here, not A, it's a negation. What's the negated statement? The negated statement is A. And here it's false in row 3. Well, if the negated statement is false, the negation is true, right? Here's the negated statement. It's false. Well, when the negated statement is false, the negation is true. So I'm going to put a true up there in that cell. And now I can move down to the last row in column 3. And that's the same as for this particular column, 3 and 4 are the same because A is also false. So not A is going to be true. So again, I'm going to put a true up here. Okay, and intuitively, this makes sense. Not A is just the negation of A. So true, true, false, false becomes false, false, true, true. Excuse me. Okay, now let's do this one, not B. Same idea. This is a negation. The main operator is this tilde. What's the negated thing? What's being negated here? Well, it's B. Okay, well, B is true in column 1. So let's look down here. When the negated statement is true, the negation is false. So I'm going to put a false right there. Now in row 2, B is false. So I'm looking at this row here. When phi is false, not phi is true. So I'm going to put a true there. When B is true, what's not B going to be? Well, when phi is true, not phi is false. You get the idea now. For this cell, B is false, so this is going to be true, of course, just the opposite. But let's go through. When this is false, this is true, so I'm going to put a T there. Okay, so now we've got the truth columns for not A and not B, the negations. Now let's do the conjunction, the final column. Okay, I'm going to start there, and I'm going to just remember I'm going to write down the, this is the truth function for conjunction that we did before, right? When they're both true, it outputs true. If the first is true, second is false, it's false, and so on. Okay, and we're going to do the same thing we did last time, except now instead of one input, we've got 2 inputs to worry about. So let's go ahead and do that. This is a conjunction. What are the conjuncts? This is the main operator. What are the 2 conjuncts? Well, the 2 conjuncts are here. I'm going to put the first conjunct outlined in red, the second conjunct in blue. So these are the 2 inputs here. What does the table say the conjunction is when the first input is false and the second is false? Well, I'm going to use red and blue down here. Well, that's down here. First input false, second input false, and it says, it outputs false. So I'm going to, up here in the truth table, column 1, output false. Okay, so notice I'm just using, I have to identify the main operator, and this is why I'm using the conjunction truth table, because this is a conjunction. What are the inputs? Well, the first conjunct and the second conjunct are here. And I'm outlining them in red and blue for purposes of this video. I mean, you wouldn't obviously do that when you're doing a truth table, but I just want to make it clear. And then I just look for that pattern down here in this function. First conjunct false, second conjunct false. First conjunct false, second conjunct false. What does it say the output is? Well, the output's false. So that's what I put in this row, is false. Now I'm just going to do the same thing for every column. Here, well, first conjunct false, second conjunct true. Where is that down here? That's down here on row 3. First conjunct false, second true, it outputs false. So I'm going to put an F up here. Let's go down to row 3. Here on row 3, the first input is true, second is false. That's right here. First true, second false. It outputs false in that situation. So I'm going to put an F. And finally in row 4, what do we have? So for this cell, first input is true, first conjunct is true, second conjunct is true. Right? Not A is true, not B is true. What does it output? Well, when both of these inputs are true, that's right here. And it says it outputs true. So I'm going to put a T right there. Now I'm just going to get rid of all of this extraneous stuff. And now this is the truth table for this statement. So if on a quiz, I said, do a truth table for this compound statement, this is exactly how you would do it. Okay, that's going to be it for this video. All I want to do for this video is just do that one truth table. What I'm going to do next is introduce the truth functions of disjunction and conditional, and do another truth table like this one, where I just step through everything very carefully. That'll be next. And that one will use all 4 operators. Okay.